It is now within our reach to automate much of the process of defining and controlling animated objects and generating high-quality images of such scenes. We can envision such a system running on a single workstation. Such a workstation represents a truly revolutionary new medium for the visualization of ideas. A tool equally powerful to the scientist wishing to simulate the world, or the playwright roughing out a new work with the help of a computer animation generated from a script. The development of such an animation environment is currently underway. A prototype set of interactive graphic tools runs on our symbolic list machine, which includes rendering and data generation facilities. Objects can be created as combinations of predefined primitives or as solids of revolution. The system provides for an interactive transformation of simplified views of objects. The color editor allows interactive specification of the colors of objects in a variety of color spaces. Here, RGB and HSV are shown. Shading characteristics can also be controlled with an interactive editor. And texture maps can be easily painted and mapped onto objects. Part of a new generation of real-time display hardware, the Trillium image generator is an integral part of our animation pipeline, allowing interactive and real-time animation previewing. To assemble graphical objects into hierarchically structured figures, we've implemented an interactive tool we call the tree editor. The kinematic structure of a jointed figure can be defined graphically and interactively. The tree editor is used to describe the transformation hierarchy, which specifies how the limbs of a figure ought to move with respect to one another. Each node in the transformation tree represents a joint of the figure, and each joint is described by 4 parameters. There are editing tools for drawing or copying segments and for handling complex figures. Integrating robotics technology into animation systems is essential to this new medium. Here, a jointed arm is following a moving object. The joint rotations are computed automatically. In this way, we can teach an animated figure to reach and grasp objects in a simulated world. Research in optical body tracking continues in a project called the Graphical Robot. This work began with a series of experiments in scripting by enactment, in which the gestures of an animator controlled animated figures directly. Hand and arm movements were extended to allow tracking of whole body motions. Our new work is based on an op-eye system with 4 cameras, which allow us to reconstruct 3D position data in real time from the images of the LEDs detected by the cameras. The next generation of body tracking experiments will make use of real-time animation and inverse kinematic algorithms so that the animator can pose figures much like life-sized virtual mannequins, ultimately to shape whole movements and perhaps one day teach motor skills by example. We look forward to integrating these tools into a powerful animation workstation as computer graphics move into the 5th generation.